So as promised, here is section 9.4. And in today's section, we are going to be looking at the different types of linear equations that we have. And the first ones that we're going to look at are parallel lines. Things we need to remember about parallel lines are parallel lines will never intersect. So if we had a line that looked like this and one that's parallel to it, it's going to run like that. So we have to think about the idea of like train tracks running. And when train tracks run, the outside lines never intersect. So they're going to just keep going on and on and on forever and never cross. They are always going to have the same slope. Okay, so we want to remember that they're going to have the same slope. That's important because sometimes you're going to be given the equation of a line and asked to write the equation of a line that's parallel to it. So if you know that they have the same slope, you just solve for the slope and then you're able to write the line that's parallel, the equation for that line. Vertical lines that go up and down, they're going to be parallel as well because they're never going to intersect. So we can remember that as well. Now, perpendicular lines, and you should remember this from geometry. If you have a line that goes this way and a line that comes this way and intersects, if they are parallel, typically what we are seeing is that they're going to have one of these little guys here, which that box means that they're a right angle. So we should remember that if they're right angle, that the lines are going to intersect at a 90 degree. Okay, we don't necessarily need to know the degrees when we're working with parallel and perpendicular lines. They're good to know and to remember, but we don't need to remember that. We don't need to know offhand because we're not going to be asked to find the angle measurements. So, but you also already had geometry, so that's just a reminder of what we did there. So slopes, notice that we have one line that comes this way, right? We had this line, it went down, and then we had, I'm sorry, that was my bad attempt at drawing. Let me actually do one like this. We have this one that comes in this direction and slopes down. This one goes in the actual opposite direction, sloping completely opposite of it. So what we want to remember is that they're opposites going in opposite directions, and they're also reciprocal. So what that means for us is that if I have something like slope equals 2, and I'm looking at perpendicular, the line perpendicular to it, the slope would be the opposite reciprocal. So instead of 2 over 1, we'd have the slope of negative 1 over 2. So again, if I have slope and it is my slope is equal to 4 over 5, the opposite reciprocal of that would be a negative 5 over 4. Okay, so it's always the reciprocal of the fraction. And if there's no number underneath, it's always a 1. Every whole number can be written as a fraction over the value of 1. So not only is it the reciprocal, but it's also the opposite. So if you start with a positive, it's going to be negative. If I started with a negative 2/3, my opposite reciprocal slope would be a positive 3/2. Okay, so if you start positive, you're going to go negative. If you start negative, you're going to go positive. So it's always the opposite reciprocal. And again, that's important to know because there are going to be times when you are asked to find the line or write the equation of the line that is perpendicular to the given line that goes through a certain point. So you need to be able to find the slope in that equation. Remember, it's always going to be the coefficient in front of your x variable. And then you're going to be able to, if it's parallel, know that it's the same. If it's perpendicular, you know it's going to be opposite reciprocal, and it'll always tell you in the wording what you need to find, so you won't have to try to figure that one out. So forms of a line. So these are things that we want to take a look at and make sure that we remember. Standard form is something we talk about a lot in math. We always talk about how standard form works. Standard form for a linear equation is ax plus by equals c. So you have your variables on the left-hand side, your constant on the right. Couple of things to remember about standard form. Your leading coefficient is always going to be off of your x, is going to be from your x variable. Okay, your leading coefficient has to be positive. And then the other thing that is really important with standard form, and I'm going to put some asterisks by this, is you never have a fraction in standard form. So if there is a fraction anywhere, whether it's the A term, the B term, or the C term, you need to clear that fraction. The easiest way to do that, and we did this once before with our fractions, is to take the denominator and multiply every single term through by the denominator, and that will remove the fraction. So on your leading coefficient, which is always going to be your A term, it has to be positive. So if it's not positive, you just either multiply through by a -1 or divide through by a -1. Both of them do the exact same thing. So it's however you want to kind of approach it. I usually say divide through by a -1 just out of habit, but you can say multiply through by -1. It's the same thing. So you want to clear the negative on the A term by multiplying or dividing through by a -1. And then the other thing that you want to make sure is that you never have a fraction. If there's a fraction anywhere in the equation, you want to multiply through by that number in the bottom. So for instance, if you had something like, let's say, we'll go with -2x minus 3y equals, let's do 2/3. 2/3. So here I have two things. It's not in standard form because the leading coefficient is negative. Okay, so our leading coefficient here is negative, and we have a fraction. So we're not following either of these two rules. So what I'm going to do is I want to multiply through by the denominator of 3 and a -1. So if I do 3 times a -1, I'm going to get a -3. So if I multiply each term, I'm going to end up having to move this for you, but we'll do it this way, by a -3. I'm just going to move this for you. Hold on. I thought I was just going to move it for you. There we go. Now when we multiply this through, we're going to get a 6x. -3 times a -3y is going to become a positive 9y. Sorry, positive 9y equals, whenever I have a negative or a denominator, numerator and denominator that are the same, they actually cancel out. They multiply out. So -1, because that becomes a 1 and that becomes a 1. So -1 times a 2 is just going to become a -2. So now this formula here, the 6x plus 9y equals -2, now that's in standard form because I no longer have a leading coefficient of a negative and I no longer have a fraction in it. So that would be the steps in how to do that. Oftentimes you're not going to be asked to do too much in standard form, but sometimes you are asked to state your answer in standard form or to take a standard form equation and turn it into y equals mx plus b. So that brings us to the slope-intercept. So slope-intercept form is probably the most common form that you ever see, which is that y equals mx plus b, where m is always your slope, and b is always, put it over here, is your y-intercept. Okay, so it's always the same. M is always the slope, b is always the y-intercept. These are standard variables that are used each time that we write this formula. So slope-intercept form, y equals mx plus b. Now, we can also use point slope form, which point slope form is, I like to use point slope form when I'm calculating out equations, because when I finish calculating, it's already in the format of y equals mx plus b. But oftentimes, students prefer to just use y equals mx plus b, and that's perfectly fine. They both get us to the same spot, so it doesn't really matter which one we use. Y equals mx plus b. The thing is, when we solve that equation, we usually end up with a number is equal to our y-intercept, to b. So then we just have to remember to go back and rewrite the equation. Y equals, put in your slope, x plus whatever your b variable is. If I plug in my slope, my x1, my y1 into point slope form, I will always get it to y equals mx plus b without having to redo it. Just remember your x and your y are the variables. All of your other letters will be numbers in the equation. So remember, your m and your b should always come out to numbers. You should never have an m and a b left in your final equation when you're stating it. So when you're writing the equation of a line, you should always have it with a number in for m and a number in for b to see those. All right, so if we're looking at slope-intercept form, this is what I just talked to you about. Remember, y-intercept is where the line crosses the x, where the y crosses the x-axis. So the line of the graph is crossing, your line of your graph is crossing your y-axis. That's your y-intercept. Your x-intercept is when the line of the graph is crossing your x-axis. So the y-intercept is where your line is crossing your y-axis. So x is equal to 0. And your b is always that line. So a lot of times you might be asked to determine the y-intercept, and you can determine the y-intercept just by looking here at this b, because that's where it's going to cross the y-axis. Because if you remember, we talked about solving for x and y-intercepts, and we plug in a 0. So if you plug in a 0 for x here, m times 0 is always going to be equal to 0, so y is always going to equal b. So they would go away. So that's how we know anytime we see the b. So once we put in y equals mx plus b, we always know what the slope is, and we always know what the y-intercept is. So it makes it a little bit easier for us. So again, this is just some additional information. I try to give you some repetitive notes, so hopefully different ways that you're seeing it, you're going to understand it. So if we're graphing it, we always want to solve the equation for y. So if it's in standard form, we want to get it into y equals mx plus b, because once we do that, it's super easy because we can just go to the y-intercept. So take the b, start at the 0 on the origin, and count to wherever the b is, whether it's positive or negative. You're going to start with your first dot there. Your first dot always goes at wherever the b is, and that, again, is on your y-axis. Once you have that, you have your slope under your m, right? So underneath this m, you have your slope. You're going to count that out. Remember, whatever it is, y over x, always count on your y-axis first, then count on your x-axis. If it's negative, so if the number is, say, negative, let's say 3 over 2, okay, you can choose to either count your y as negative or your 2 as negative. A lot of times, let me rewrite it. I want to write it a different way. A lot of times you're going to see it in this way. You're going to see it as a fraction, and you're going to see the negative out front, and it's even with this fraction bar. And the thing is that you can either put the negative at the top with the 3 or at the bottom with the 2. It doesn't matter. It's your choice. It's one of those things that can kind of float wherever it wants to go, and it's not going to change it. It's just you have to remember you can only count one of the numbers as negative. If you count both of the numbers as negative, it's going to cause your slope to change and become positive, because a negative divided by a negative becomes a positive. Because remember, anytime you see a fraction, we have to remember this bar in the middle, the fraction bar, is the same thing as division. So it doesn't change it. It's just we're seeing it in a different way. So we don't want to have both the numerator and the denominator being negative, because if we do, it becomes positive, which then is going to flip your slope and it's going to become all positive, and you don't want to do that on your problems, okay? So once you have your slope, you're going to count it out. So in this case, let's say that our b, let's give our b a value. We'll go with a positive 6. So if our b is 6, we would go on the 6 of the y-axis. So we would start at the origin, count up 6 units, put our dot at the 6. Then we would count down the y-axis 3 units, and then across to the right, positive 2 units, and put another dot, and then you connect those 2 points. Okay, you guys should have done some of this in Algebra 1, so it should be reviewed for you. So remember the the y over the x, and always connect your dots. Don't leave your dots unconnected, because then they're just points on a coordinate grid, and we should remember the difference between a point and a line. A point is just a single spot, and with linear equations, we're looking for the actual visual representation of the equation, which is the full line. So we do not want to leave it with just the points and not the line. So if we are finding the equation from a graph, we can find the y-intercept, which is your b. So you can go right on your graph and find that y-intercept. So I'm just going to draw a quick graph here, see if we can put one, and we're going to estimate where we are because I don't have a regular graph here. But if we have our coordinate grid, and then we have a line, let's go like this here, we have to figure out what is this point right here. Okay, and let's estimate that and say that we'll call it 3. Okay, so if we say the y-intercept b equals 3, we'd have that. Then we would count out our slope. So we would want to count down and across. So if we count down 1, 2, 3 to our 0, and then let's go across, and we're going to go 1, 2, we'll say it's 3 over. So we counted down 3, so minus 3 and plus 3. And most of the time you're going to have your units listed out for you, so you don't have to guess. We're just guessing that that's 3 over 3. So it's a negative 3 over a positive 3. So if we calculate that out, we would say our m is equal to a negative 1. So our m is equal to negative 1, which means that if we wrote this equation, we would say y equals negative 1x plus 3. And that would be our equation of that line. Okay, we don't technically have to write the 1 there. We could just write negative x plus 3. It's the exact same thing. Okay, and now if I gave you 2 points as opposed to the actual graph of the line, what you would do is you would have to use the slope formula and write the equation of those 2 lines using the points. So you're going to do m equals y2 minus y1 over x2 minus x1. Once you get that slope, if you can see the y-intercept, use your y-intercept. If you don't, then you're going to use the points and plug them into either y equals mx plus b, or your point slope form, y minus y1 equals m times x minus x1. These are some more notes for you. Forms of the linear equations. We talked about standard form. We talked about y equals mx plus b. This is the formula for point slope form. Standard formula for horizontal line and vertical line. This is the information for parallel and perpendicular lines. So you can have these. Remember, all your notes that I give you in class you can use on tests and quizzes. So this information might be useful for you to print out so that you have access to it. Now, so we know that with math stuff, they always give us some things that have multiple names. Slope, rise over run, rate of change, average rate of change. All those mean the same thing. They're all slope. Well, functions come into play when we are talking about linear equations. And we're going to see functions multiple times throughout your algebra. Okay, so function equations are all that basically does is, notice we take the y and we replace it with this, the f with the x in the parentheses. This is read as f of x. So it's the function of x. Notice they're saying y is equal to f of x because they're the exact same thing. They mean the same thing. It's just 2 different ways of showing it. You might say, well, why are they showing us in 2 different ways? And the reason is that f of x is a special notation. It means that it's a function. They're telling you it's a function. And if you remember back to the beginning of this section, when section 9 altogether, when we talk about a relation, when you have coordinate points, every set of coordinate points are a relation, but a special relation when you have no repeating x values becomes a function. So we are just taking the y equals and replacing with f of x to let you know it is a function. That means there's a one-to-one relation, meaning there are no repeating x values. So the graph of this function is going to be a straight line. So we don't have to question it any longer. So that's the reason why we do it. Just remember, anytime you see the f of x or the f with the parentheses x, it's not multiplying them. It means f of x. Okay, so it's just special notation. It does not mean f times x. And you're always going to see it like this. Now, I don't always have to use f. I can use g of x, h of x, j of x, k of x. I can use any variable that I want. A lot of the times, you're going to see f of x or g of x or h of x. Those are the standard typical ones that you're going to see, but we can interchange them all. It doesn't really matter. So it's not going to change anything. So the final thing that we're going to talk about is evaluating a function. So we have to understand that as soon as I put a number where the x is, here we have the 3, all I'm going to do is it's telling me exactly what to substitute. It tells me that x is equal to 3. So what I'm going to do is I'm going to take that 3 and I'm going to substitute it in everywhere where there's an x in the equation. So right there, there's an x. So I'm going to say f of 3 is equal to 3 plus 2, or 5. So I'm telling you that at the x coordinate point, your y is equal to 5. So I could tell you at this point, the coordinate point is 3, 5. Then if I said f of 0, I take the exact same function, that x plus 2, and I'm going to plug in a 0 for x. And now I'm saying that if x is equal to 0, y is equal to 2. Because remember, f of x is the same thing as y, so it's just substituting that value in, okay? So it's not changing that. So we just want to make sure that when you have that value of x, you substitute it in for x. It's just basically telling you x is equal to. So that's how we're substituting it in. All right, so that is everything that I am covering with you guys for linear equations. I've given you all your notes. They're all posted online. If you have any questions, please let me know so that we can go over them. You can send me an email. We can schedule a time to talk. If there's another math teacher at the school you'd like to speak with, you can speak with them and they will help you out.